I'm going to talk about rotations in this lesson. It's another type of transformation. So we're going to start off with just figuring out what a rotation is. Like I said, it was a transformation, and it's going to turn every point a certain degree, in other words, some angle measure, and a certain direction. Now that direction is either going to be clockwise or counterclockwise. And I have a picture here of a rotation. I have my quadrilateral ABCD has been rotated to end up on quadrilateral A prime, B prime, C prime, D prime. Now, the parts of a rotation, one would be the center of rotation. That's a very important part. That's the point that we're going to rotate everything about. So in this case, point R is my center of rotation. Everything's rotating around that point. And then you have your angle of rotation. Well, that's the measurement of the angle that we're rotating from pre-image to image. So in this case, when you look at it, my angle of rotation, or one example of the angle of rotation, would be angle dr d prime. And just to kind of highlight that, I've shown it here. It shows you where D starts and where D prime it will end up at, and notice R is the center of rotation. Now, it's not the only one that we could have used. I could have also gone to, I could have taken any one of those points. Let me just highlight. I could use, for example, the one that this is using. It's using P ending up on P prime. If you were to measure both of those angles would be equal in measure, because it's the same angle of rotation no matter what point you're rotating. So that's what a rotation is. Now, I'm going to look at this one little example and show you how to actually rotate using a compass and a straight edge. And I want to take my segment AB and I want to rotate it 120 degrees clockwise about point C. So point C in this case is my angle of rotation, or excuse my center of rotation. The 120 degrees is my angle of rotation. So to do this, I have to make a 120 degree angle. Well, being point C is the angle of rotation, that has to be the vertex. So I'm going to connect my vertex to one of the points I want to rotate. And I'm going to have to do this twice because I have essentially 2 points to rotate, and then I'll connect them with my segment. There's one part of my angle. Now I have to make the other side of my angle. I'm not doing that though. Let me undo that. This is where the protractor comes in. I have to figure out where is this 120 degree angle going to be. So I line this up, and now I look at this, and if I start at my 0 and I follow my protractor around, I am going in, notice this, a clockwise rotation. So I have my protractor going the right way. Now, had I wanted to be counterclockwise, I'd want to have my protractor more like this, because now my 0 right here, and I would be going this way. Now that would be a counterclockwise. But being it's a clockwise rotation, I need to have this set up the right way. Spin it back around. And then I'm going to put my little mark at the 120 degree spot of my protractor. And then I can make the other side of my 120 degree angle. And I have it. Now somewhere on that ray that I just made is my A prime. I just have to figure out where it is. That's where the compass comes into play. Oops. I need to take my compass and put the point of the compass, get my protractor out of the way, take the point of my compass and put it on the vertex of the angle, and then I need to measure this. Nice, I already have it done. I have it figured out how far it is from point C to point A, and now I just need to come over here and I need to make that little arc on this side of the ray so I know where A prime is going to be. So the intersection here, this is going to be my new A prime. I've already rotated point A. I just have to do the exact same thing to rotate point B. Move that out of the way a little bit. So it's going to come back. We're going to, remember, make one side of our 120 degree angle by connecting the center of rotation to the pre-image. And then I have to make my 120 degree angle. I don't know how many times I'm going to do that today. It's all lined up. I have to make a little adjustment to get that back to my vertex of the angle, the center of rotation. Come down here, follow my numbers around until I get to 120 degrees. make my other ray. There we go. Take my compass, put it up here. And I think I'm going to have to move this protractor just to get it out of the way. Oops. Now this time I'm going to have to bring my compass in a little bit. Have it measured the distance from my center of rotation to my pre-image. I'll come down here to the other side of my 120-degree angle. Oops, and I just moved it. That was not what I wanted to do. There we go. Bring it over here. Make my arc. Now I can get try to get my compass out of the way here. And now I know that B prime is going to be right there. And then I can just connect the dots with the segment. What I'm going to do is I'm going to change the color of that just so we can see it a little bit better. I'll make it that green color. So what I've done now is, using my compass and my protractor and essentially a straight edge, is I've rotated segment AB over here to segment A prime B prime using that 120-degree angle and in a clockwise rotation. Now the next thing dealing with rotations would be rotational symmetry. Rotational symmetry is when you take a figure and you rotate it some degree, less than 360 degrees, and that figure will land on top of itself. So what I have here is I have an example of something that has rotational symmetry. This regular hexagon has rotational symmetry. Now there's a couple pieces that follow after rotational symmetry, one being the order, and that's going to be the number of rotations less than 360 degrees that place that image back on top of itself. So if I can turn the figure or rotate it and it lands on top of itself, that gives me one order. If I can turn it another angle measure, there's two, and we can continue on until you've found them all. Now, the kind of tricky part about this one is when I look at this, so what I've done is I just have two of them sitting on top of each other to help us count. Now what I can do is I can take, I'm just going to follow that red segment. I can rotate that here. There's one. So that would be an order of one. If I come back here, that's how it started. And then that red segment could rotate all the way down here to the kind of this pink or purple. That would give me two. I can rotate the red all the way down to the bottom. I'd call that a purple. There's three. I could go all the way around here to kind of this brown color. There's four. And then I'd rotate all the way around until I hit the blue. There's five. And you think, well, there it is, because if I do this and I rotate all the way around, well, that's just the same thing. So a lot of times you think the order is 5. Unfortunately, that's wrong. The order here is actually 6. And here's kind of the way I think of it. A figure will not have, or will have, if it has an order of at least 1. In other words, if you can take that figure and rotate it at least one time so it lands on top of itself, then you get to count the 360-degree rotation as well. But if you can't get it to rotate on top of itself at all, then it doesn't get the 360 degrees. Kind of a little, I don't know, maybe flaw in the system, however you want to look at it, but if you get 1, it has to have 2. So anytime it asks for order, the smallest order it can ever have is 2. So if you can rotate it 180 degrees, then you get to count the 360, so on and so forth. Now, the next one is the magnitude. And the magnitude is the smallest angle measure in which you can rotate it so that it lands on itself. Well, in this one, it would be whatever this one is. So I could go there, or if I went back this way, it'd be the same angle measure, just a different direction. So the question is, what is the measure of this angle from here to here? And here's how you figure that out. Find the center of rotation, which would be approximately here, and then connect that center of rotation to some point on your figure. And then you got to ask yourself, well, where does this point end up after I rotate it that smallest angle measure? Well, the answer is it ends up here, and then I connect it. Well, the question now is, where does this point end up after I rotate it? It's going to be here, connect it to my center, of rotation. Where does that one end up at? Here. I connect it. Where's that one end up? Here. I connect it. And hopefully you're starting to see this pattern. This point is going to end up here, and I connect it. And finally, this point is going to end up right back where I started. Now I look at this and I go, well, I have 1, 2, 3, 4, 5, 6 angle measures in there, which is going to help me calculate the magnitude. Because if I were to add up all 6 of those angles, it would equal 360 degrees. Well, if I take 360, divide it by the 6 angles that are in there, I'm going to get a 60-degree angle. So the magnitude for this regular hexagon is 60 degrees. So remember, order is how many different ways can I rotate it to have it land on itself in one direction only. Don't count clockwise and counterclockwise, so just one direction. And also remember that if it has an order of at least 1, then you get to count the 360-degree rotation as well, so then it would have 2. 2 is the smallest order you can have. And magnitude, it's that smallest angle measurement that is going to allow that figure to land on top of itself. That's where I'm going to conclude the lesson portion of the rotations.